First, we'll be finding the Lewis dot structure for silicon 2, fluorine 2, hydrogen 2. Silicon has 4 valence electrons. Because there are 2 molecules of silicon, you double the amount of valence electrons, making the total 8. Fluorine has 7 valence electrons. 7 multiplied by 2 makes a total of 14 valence electrons. Hydrogen has 1 valence electron. Multiplied by 2, the total is 2. Now we have to add the totals of valence electrons for each molecule. 8 plus 14 plus 2 equals 24 valence electrons in total. Now that we have the total amount of valence electrons, we divide it by 2 to find the pairs. The amount of pairs is 12. We then subtract the number of unshared pairs from the total pairs to calculate the bonds. We have 3 unshared pairs in fluorine, but because there are 2 molecules, we multiply it by 2. 6 unshared pairs subtracted from 12 equals 6 bonds total. For the Lewis dot diagram, we start with the 2 silicon molecules. A pair is formed in the middle of the molecules. We draw a line to indicate that is now a bond. We then put fluorine on both sides of the silicon molecules. Between the fluorine and silicon molecules, we form 2 bonds. Next, we add the hydrogen molecules to the top of the structure. They both form bonds on the top of the silicon molecules. Now we have 5 bonds. To make the 6th and final bond, we combine the 2 silicon valence electrons in the center and make a double bond. Now we are done with our first Lewis dot structure. For creating the Lewis dot structure for permanganate, we again start with finding the valence electrons. Manganese has 7 valence electrons in total. Oxygen has 6 valence electrons, but because there are 4 oxygen molecules, you have to multiply 6 by 4. This makes 24 valence electrons. Now you add 7 plus 24 with an additional 1 that comes from the -1 charge. The valence electron total is 32. Now we will make the Lewis dot structure. Because manganese has 7 valence electrons, there will be 7 bonds. First, we put the manganese molecule in the center, surrounded by 4 oxygen molecules on each side. We then make the bonds between each molecule. Because there is a total of 7 bonds, we have to add 3 more. Now 3 of the bonds have been made double bonds, and 1 is left as a single bond. Now we will continue to add the correct amount of valence electrons to each molecule. 2 of the valence electrons in each oxygen molecule were taken to form the double bonds, so each molecule will now have 4 valence electrons. However, the molecule with only a single bond is left with an odd pair of valence electrons. The 1 valence electron cannot be left alone, so we have to add an atmospheric electron to make it complete. We surround the structure with brackets and add a negative sign to symbolize that it is a polyatomic ion with a negative charge.